Satellites sound like shiny trivia until you notice your phone, your weather app, and half the global economy are basically borrowing their sense of direction from a few metal boxes falling around Earth at several miles per second. Stay with me, and you'll never look at no signal the same way again. Hello, my name is Gene Botkin. I study space and its growing importance in our daily lives. And I'm building a society for people who want to participate in the new space age. Our topic today is what satellites are used for. Let's begin. Start with the boring definition, because boring is where the power hides. A satellite is a human made machine placed in orbit to do work from above, whether that work is watching Earth, relaying signals, or studying space itself. It's like outsourcing your eyesight to the sky. The first use is simply being in the right orbit. Some satellites sit far out and stare at the same region constantly. Others sweep pole to pole and build a global picture over time. The job decides the orbit, and the orbit decides what you can reliably measure. Communications is the classic. Satellites act like extremely expensive cell towers that never get zoning approval from your neighborhood association. They relay voice and data across oceans, mountains, and anywhere else cables would rather not go. The sky is a very patient middleman. Broadcasting is the older cousin who still pays bills. Satellite TV and radio move content over wide areas without building a spiderweb of local infrastructure. It's one-to-many distribution with a clean geometry. One satellite, many dishes, many viewers, many complaints about the price. Satellite broadband is the newer headline, and it's not subtle. Large constellations are built to push internet access into places that have terrain, distance, or politics working against fiber. The pitch is coverage and speed. The reality includes lots of regulatory paperwork and orbital traffic. Direct-to-phone satellite service is the next step in the same story. Instead of a dish or a special terminal, the goal is to let ordinary phones connect for basic messaging and emergency coverage. It's the kind of feature you ignore until the road trip gets interesting. Navigation is the one everybody thinks they understand, mostly because a blue dot makes them feel emotionally supported. GPS works because satellites broadcast timing signals, so your receiver can compute position. The satellite isn't telling you where you are, it's giving you time, very precisely. Timing deserves its own spotlight, since it quietly runs modern life like a stage manager who never gets applause. GPS timing synchronizes telecom networks and other critical systems, which is why people worry about dependency and resilience. When time slips, weird things follow. Weather satellites are the public service workhorses. They feed observations into forecast models and help meteorologists see storms as systems, not as local surprises. When the forecast improves by days, it's often because satellites made the atmosphere legible at scale. Some satellites are built for short-term forecasts. Others build long records that let scientists track long-term trends. NOAA's polar satellites support operational forecasting and also extend decades-long datasets that are used to study climate patterns. The same sensor can save lives and answer slow questions. Disaster response is Earth observation with urgency. Satellites help map floods, fires, and storm impacts when roads are gone and aircraft can't get in. The point is speed and coverage. Show responders what changed, where it changed, and what still needs help. Agriculture is a daily use case that looks boring until you realize food is a national security topic with better marketing. Landsat data supports crop mapping and planning, and it's used to understand yields, conditions, and resource use. The planet is a farm, and the sky takes notes. Water management is another quietly huge one. Satellite data can help estimate irrigation consumption and track drought conditions, which matters a lot when water is scarce and arguments are plentiful. Seeing water stress from orbit is less dramatic than a courtroom, yet it's often more useful. Forestry and wildfire monitoring also lean on satellites. With repeated imagery, agencies can track burn scars, recovery, and fuel conditions over time. It's a long game. Measure, respond, learn, then measure again. The forest forgets, the satellite doesn't. Urban growth and land use change get tracked the same way. Satellites document how cities expand, where development pressures land, and how infrastructure reshapes landscapes. If you want to argue about planning, bring satellite data and save everyone 3 hours of shouting. Oceans are harder than land because they move and they hide their structure. Satellites measure sea surface temperature, color, and other indicators that feed ocean forecasting and environmental monitoring. You can't put weather stations everywhere in the sea, so you put eyes above it. Sea level monitoring is one of the cleanest examples of why space-based measurement matters. Altimetry missions like JASON measure sea surface height and support work on sea level rise, ocean circulation, and even storm understanding. They're basically orbiting tide gauges with ambition. Ice and snow monitoring matters for water supply, climate indicators, and shipping. Environmental satellites track snow cover, sea ice extent, and related variables that affect everything from forecasts to long-term planning. When you hear polar changes, someone is usually reading satellite data. Air quality and atmospheric monitoring is another big category. Satellites measure gases and aerosols that affect health and climate, turning invisible chemistry into something you can map and compare across regions. People argue about air quality like it's subjective. Then a satellite shows up with receipts. Aviation cares about the atmosphere in a very practical way. Space-based monitoring supports warnings for hazards like volcanic ash, which can threaten aircraft engines and routes. It's hard to negotiate with a cloud of ash, so the better strategy is seeing it early and rerouting. Science satellites look outward as well as down. Some are basically observatories in space, doing astronomy without the nuisance of Earth's atmosphere getting in the way. The public thinks this is the cool use, which is fine, because awe is a legitimate budget strategy. Solar observation is practical science with a side of majesty. Satellites watch the sun and the solar wind because space weather can affect systems we rely on, including communications and navigation. The sun is generous with light and stingy with predictability, so monitoring helps. Planetary orbiters are also satellites, just not Earth's. Missions like lunar and Mars orbiters map surfaces, scout landing sites, and run long-term measurements that build real knowledge of other worlds. It's slow, meticulous work that still manages to inspire, which is rare. Satellites also serve as testbeds for new technologies, sensors, communications links, autonomy, and new approaches to gathering data. The point is to prove something works in the harsh environment where physics collects all debts. Once it works there, it usually works anywhere else. Search and rescue is one of the most humane uses. Satellites can detect and locate distress beacons worldwide, turning a desperate signal into a map point for responders. It's one of the few technologies that can convert pure panic into a structured workflow. Maritime tracking is a whole industry. Satellites can receive AIS messages and extend ship tracking beyond coastal receivers, supporting maritime awareness and safety. It's also a reminder that the ocean is big, people are sneaky, and paperwork travels faster than ships. Radar satellites, especially synthetic aperture radar, deserve a special mention because they see through clouds and darkness. That makes them ideal for floods, ground movement, and other events that happen when optical cameras would rather take the night off. Radar is unromantic and relentless. Intelligence and reconnaissance are a major driver even when details stay classified. Agencies develop and operate space reconnaissance systems that collect imagery and signals for national security purposes. You don't get a press release for most of it, which is in a way the point. Missile warning is the clearest seconds matter mission. Infrared sensors in space can detect the heat signatures of launches and provide early warning to decision makers and warfighters. It's grim work, yet it's also a form of restraint, since warning time reduces the chance of miscalculation. If you pull all this together, satellites are the hidden scaffolding of modern life: communications, navigation, timing, weather, disaster response, science, and security. They amaze because they're so ordinary. You forget them, right up until they fail, and everyone becomes a philosopher about dependency. If this helped, like the video, comment below with the most surprising satellite use you hadn't thought about, and subscribe for more space in plain English with a little dry amusement. This has been Gene Botkin with Eleonarda. End transmission.